Number 1, determine if the 2D figures below have reflectional, rotational, neither, or both type of symmetry. All right, so let's go through all of them and do reflectional. Okay, look at A. Reflectional symmetry is, of course, where you can draw a line of symmetry, and everything on one side of the line is like a mirror image of everything on the other side of the line. So that figure would have reflectional, oops, my alignment's off, sorry. It would have reflectional symmetry at every triangle on there. And then it would also have it in between the triangles. So this one would have a lot of lines of reflectional symmetry. This one would have 2, this one would have 0, this one would have 1, and this one would have 0. So we're good with reflectional symmetry. I could fold it and it would look the same on either side. Angle of rotation. All right. First you want to look at, is it symmetrical like in a circle? Could I rotate the figure? And when I land, the figure looks the same as when it started. It should look no different. It should be congruent. So could I rotate that sun a certain number of degrees, and when it lands, it looks just like the sun looked before? It's not off a little bit. Well, yes, I could. And to find the angles of rotation, you always take 360 degrees and you divide it by how many points there are, or how many parts where I could rotate it a little bit, and I would land where I started. Rotate a little bit, land where I started. Every time you could rotate it and land where you started, you count those up. There was 8 in the sun, and so then you just divide that number into 360, the number of degrees in a circle. If you're not in radian mode, right? Okay, this one. If this is a true rectangle and not a square, then I could rotate it not 90 degrees, right? If I rotated it 90 degrees, it would not look like it started, but if I did a full 180 degree rotation, it would land where it started. So this one has just 1. This one had 8. This one, when this arrow becomes this arrow, that's a degree of rotation. When it becomes a 0, that's a degree of rotation. So 360 divided by 3. This one has 0, and this one has 0. In a kite, even if I rotate it 180 degrees, it'll still be going horizontal, but the long sides and the short sides will be kind of switched. 3B got cut off a little bit on your review. So this should have said 2.5y parenthesis close like that, okay? So the way that we're going to do that is we're going to find the coordinates of our original points, and we're going to take all the x values and we're going to multiply them by 1/2. We're going to take all of y values and we're going to multiply them by 2.5. So that's what that means right here. That is also called a scale factor. Now, what does multiplying by 1/2 do to a coordinate? So multiplying by 1/2 would, if you were doing it to the whole shape, which we're not, it would shrink the shape. It'd be half the size. Multiplying by 2.5 would be like doubling it and then 0.5 more. So what this is called non-proportional dimension change. You are not changing that shape proportionally. Normally, when you have a scale factor, if the shapes are similar, then that means that every dimension is changed in the same way. It's a proportional change. This one is a non-proportional change. So the coordinates of D are -3, 2. So how would you apply this change to it? You would do -3 times 1/2. And you can write that as a decimal or a fraction. They kind of mixed it up in there. They wrote 1 fraction, 1 decimal, so whatever. -3 halves x, comma, and then I take this and multiply it by 2.5. Sorry, didn't mean to put the x. -3 halves, comma, 5. So you would go -1.5, and then you would go up 5. It's kind of hard to describe the change because it's doing two things at once. It's kind of like shrinking in the x values, and then it's like growing in the y values. In number 4, we are taking these values and we're trying to determine if a triangle is acute, right, or obtuse. This is Pythagorean theorem converse. And when you think converse, you should think reverse. So when you're doing these problems, you're going to write Pythagorean theorem, and you're going to write it backwards. 15 squared, and you're going to compare it to 5 squared plus 12 squared. 15 squared, 225. 5 squared plus 12 squared, 169. And the answer is obtuse. It's actually correct on the key. So you read the problem. We read from left to right. That's how you read a book, right? So 225 is greater than. It's greater than. It's how you. Since that's a greater than symbol, greater than goes with obtuse and less than goes with acute. Greater than, obtuse. All right, 4e is a little bit weird. It almost looks like it's x root 2, right? 9 root 2. But it's not. It's 9 root 2, 9 root 2. So that is an isosceles triangle, right? So anyways, we'll find out what happens in a minute. So I'm going to take one of the 9 root 2's, and that's going to be my c squared. I'm going to take the other two, and those are going to be my a and my b squareds. Is everyone okay with that? 9 squared is 81. 81 times 2. This is 162. So this one is definitely going to be bigger, right? It's 162 plus 9 squared. I mean, it's going to be a lot larger. 162 is less than 243, therefore, totally get it. Okay, number 13. So let me remind you what an angle of elevation and an angle of depression are. Angle of elevation is when you're on the ground looking up. That is called your line of sight, and the angle of elevation is right here. It is created with the horizontal and your line of sight. That's an angle of elevation. Now, an angle of depression is when you are up high, now you're up here, you're looking down. This is still your line of sight. The line of sight doesn't change, but it's the line of sight formed with the horizontal. That's your horizontal, and so that right there is the angle of depression. Now, what's important to know is that the angle of elevation and the angle of depression are always congruent. They are the same angle every time, all the time. So if you just convert, well, you don't even convert. If you just call this the angle of elevation, every time you're going to be okay. In other words, if you put the angle on the ground every time, you can't get it wrong. What students do is they think it's the angle of depression, so they end up putting it right here. It doesn't go there. If I wanted to do it perfectly correct, I would draw this dotted line and I would put the 37 here. But then I could do alternate interior angles and I could put it on the ground. They are not the same thing, but they're the same measure. They're always the same measure all the time. But they're not the same thing position-wise. But they always are congruent. 39b is a pentagon. That problem being a pentagon makes it a much harder problem, right? Because it's not a special right triangle. Let me remind you that in the hexagon, you're going to have 60 and 30 and 90. And so you can do, 10 root 3, 20. But you cannot do that same thing in the pentagon. So let's find out how we're going to find the side of the pentagon. I'm going to put an X there, but we're going to remember that that's only half the side, that's not the whole side. Okay, now we need to find an angle. We know we have to use trig. We can't do trig without an angle. There are 360 degrees in a circle, and if I drew every one of these triangles, I don't know if you can kind of see what I'm doing, but you don't have to do that. If I drew them all, if I drew a triangle everywhere, which would make my picture too messy, I would end up drawing 10 triangles. It's 2 per side, and there's 5 sides. So I take 360 and I divide it by 10, and I get that angle is a 36-degree angle. I'm going to draw it larger. 36, 12, X. opposite, adjacent. So that's tan 36 equals opposite over adjacent. Where is x? All right, I'm just going to follow this one through and we can fix the rounding if we need to. X is in the numerator, so we multiply. 12 times tan 36. We get 8.7185. We leave it in our calculator, right? We double it. Now we have a side. One of the sides is 17.437. Now we multiply it times 5 because there's 5 sides. Now we have a perimeter. Perimeter is 87.2 something, 0.18. And now we multiply it times the apothem times 12 divided by 2. So the more exact answer would be 523.11. It didn't say what to round to, so it's not a big deal. You're not going to have an answer choice that says 522 and an answer choice that says 523. You know what I mean? You're only going to have one that's close. 53. The fabulous thing is that these are cubes, and all cubes are similar to one another. So this is proportional dimension change, which is kind of nice. Let's find the scale factor first. Scale factor, second over first. Second over first. So the scale factor is 3. Those sides, those dimensions are 3 times larger. Now here's where we do the 1D, 2D, 3D thing. Am I going to find the volume? No, I'm not. If the scale factor is 3, then the volume is 27 times bigger. If the scale factor is 3, then the surface area is 9 times bigger. I didn't find the volume. I didn't find the surface area. I used proportional. 55. Okay, here's how you do 55. This is not proportional change. Do you notice how the sides are not changing in the same way? So I want you to find the volume of the first one. I know, it's weird. Find the volume. 2x times 2x times 5x. 2 times 2 is 4, 4 times 5. Okay. So the volume of that first one is 20x cubed. The volume of the next one, let's just multiply them. 4 times 6 times 12.5. The volume of the next one is 300x cubed. So I want to know how many times bigger the volume is, and that's just a division problem. Second over first. So 300 divided by 20, and you get 15. The volume will be 15 times larger, 15 times bigger, 15 times more.